Hi, can you hear me? Can somebody confirm if I'm audible?
Yes, sir, you're audible.
Okay. Okay, we will start at 7 p.m. sharp. So just waiting for more students to join. Okay, so we will begin in 1 minute, but before that, just to gather some information about the students who are going to attend this program. So I would like to know from you how many of you have already appeared for the M Prakash Institute entrance test, which was conducted before, I think one month ago, roughly speaking. Can you raise your hand if anybody has already given that exam and this will be your second attempt? Or are all the students going to give the exam for the first time now?
No, sir.
Okay, so you have
First
not given
time.
the exam before. First time. Okay, okay. And have you already joined any other, like, because we many classes have foundation programs these days, like from 8th standard onwards they start to train the students. So has anybody already attended any kind of program like that, or you are just coming from your school level syllabus? So just want to understand what is the other exposure or what is the back preparation that you have already done, which will
So
help me to decide the difficulty level.
I am in M Prakash Institute for 2 years batch.
Okay, okay, okay. What about others? Anybody who is already doing some class or just going to appear for this exam?
Sir, Allen Institute, Nanded.
Alan. Okay, yeah, okay. So that is good that wherever you are having some. Sorry, somebody was saying something.
I've only done school level. I haven't done any extra
Okay,
coaching.
okay, okay. Fair enough. So yeah, I mean, as such, this exam is designed in such a way that we don't expect you to have done any other coaching. That just based on whatever is in the school syllabus, that should be sufficient to do well at an exam like this. But the difficulty comes in application. So that is what we are going to see today. That how you take the concepts and apply them. Uh, that is where the difficulty starts. But anyway, let us begin. So hi, welcome everybody to this program. So my name is Prashant, and this is the second year that we are offering this course. Last year was also we offered the same course, and lots of students gained valuable insights into how to solve the paper, and in general, not just about solving the paper, how to organize your study for an exam like this. Because the same things that we are going to do now to prepare for this exam, think of this like a short or mini version of JEE, that you have to apply the same principles, same problem solving or study habits to scale your performance all the way up to JEE. No matter which institute you get selected, that doesn't matter. Okay. Uh, so just to introduce myself, so I actually was a student from M Prakash Academy back in almost 18 years ago, and I also graduated from IIT Bombay. After that, started working as a software engineer, but side by side, I was also involved in mathematics Olympiads at various levels, first as a student, then as a teacher for many years. So, I mean, honestly, my experience with mathematics is more than the other subjects in this regard. But still, surprisingly, when I gave JEE exam, my physics score was more than my mathematics. And I will explain shortly why that is the case. But finally, it comes down to the idea that the maths is the foundation of all the engineering that you are going to do. And so maybe it would be useful to talk about how to prepare for physics. So there are two things in physics, right? One aspect is learning the subject well, and the other is performing well at the exam. So this course, I'm just going to give you the idea about how to do well at the exam. But apart from that, like physics itself is a very wonderful subject. So you should spend a lot of time understanding the concepts and appreciating them. But regardless of that, know how to apply those ideas in the exam is what we are going to focus on in this course. So yeah, the first 1 week, so this lecture and the next two lectures, I will cover physics, and then Soni madam will cover chemistry, and the last week we will come back to mathematics. Okay. Uh, some general ideas before we actually start to solve the problems. So we are going to cover two practice paper, like two past question papers. But in general, what are the things that you should keep in mind as you know you are approaching any new problem? So these are general steps which are applicable for any subject, not just for physics. So the first thing is that typically you are given a word problem. So this is something that you also do at school level. So it is not like you are not used to word problems. That there is some information which we have to convert into variables. So some information is given, some information needs to be computed. These two parts are typically what you do at the school also, that something is given and you have to find something. But what makes these questions bit more challenging than school level is that typically there is not just one formula or one step to go from the start to the end. Often you have to take multiple small steps, find one variable, then find one more variable, have some intermediate unknowns and those kinds of things. So, having a good idea about all of these variables, what are the important formulae. So, knowing all of this well is very important. Once you have all the information converted into equations, then the second step is just to solve the equations. So the second step is just mathematics. That is where again the mathematics is very important. That being able to solve the equations efficiently, accurately within the time. So all that matters at the step two. And then step three is um, also important. Sometimes people don't pay enough attention to step three, is converting the final answer back into the original context, like whether it is a physics problem or a chemistry problem. So, interpret the information back into the original question, because sometimes, mistakes can happen at this step. Uh, for example, maybe you have solved a quadratic equation and that gives you two roots, right? So mathematically speaking, both roots are valid, but maybe we are talking about the mass of an object and one of the root is negative. So then we know that the mass cannot be negative. So eliminating that other root and things like that. So the step three is important for that. Okay, so these are the general, this is the overall process to solve any problem at this level. But for physics in particular, there are few other things that we should do to help us to solve the problems more efficiently. So the first thing is drawing a good diagram. Okay. So I mean, it doesn't have to be geometrically accurate, but it has to be like a schematic. How are the objects positioned? Like if there are some objects are falling, some objects are moving from one position to another. So showing the snapshots of various times, that at time like t equal to 0, this is the situation. Then after a few seconds, this is the situation. So drawing the diagrams, showing the important forces, that if there is gravity, if there is electric charge, etc., etc., whatever forces are involved in that question. So that is very important, and I'll show you some techniques that how to draw the diagram, which conveys all the important information. Then sign convention is another important point, that often we have a question where some values are like some object may be traveling to the right, but the force is acting to the left, or those kinds of confusions can be there. So if you are not careful, you might miss one sign here or there and get the answer wrong. So having a clear, consistent logic, that how which quantity you take positive, which you take negative. So if you are consistent, then you can be confident that your answer is correct. And the same goes for units also. Like often maybe question will confuse you with giving different information in different units. Like some might be in meters, some might be in centimeters. So pick one unit system like MKS or CGS system and convert all the information into that system before you start to solve. Okay. There are some exceptions. I will show interesting. There is one problem here which we will do today, where I mean, so again, all of these are general principles. There is no fixed like what you can say golden rule that you have to follow this 100%. Sometimes you have to be a little bit more proactive and take shortcuts to save your time. So I will show some examples that where
प्रशांत,
you can.
एक
Right.
एका मुलाचा आत्ता फोन आला होता. त्यांना मी आत्ताची
Uh-huh.
लिंक पाठवली. त्यांना म्हटलं आजचं
Okay.
लेक्चर अटेंड करा, मग फॉर्मॅलिटी करू आपण. हं. तर
हो, हो. चालेल ना,
तो
हरकत
जॉइन
नाही.
करेल आता. त्याला एंटर करून घेशील.
मी एनिवे हे वेटिंग रूम
ओपनच
डिसेबलच
ठेवलंयस
केली
ना?
आहे. हो,
ठीक
हो,
आहे.
हो.
ठीक आहे. ठीक. ओके.
हां. ओके. Okay, so at times you have to take some shortcuts, to save time. So I will point those out from time to time, but these are the general principles that you should follow as much as possible. Okay. So all of this was what you should do when solving a question. But even before you go to the exam, you have to do a lot of back preparation. This is the homework that what you should do for the next few weeks, to have the best possible chance at doing well at the exam. So the first thing, as I said, is that, knowing the concepts very well is very important. So we will not have the time to cover this in our course because we are focused on the problem solving, but this is your homework, that make sure you know all the basic laws of physics, like what are the equations of gravity, of kinematics equation, conservation of energy, momentum, etc., etc. Every topic has some important concepts that you should know. So you should know the concepts, and also you should know the formulae. So the formulae are what will give you the problem solving techniques that, for example, in kinematics equation, you know how to calculate the velocity, the initial and final velocity, or the displacement, things like that. Newton's laws of motion, density, buoyant force, etc., etc. But what is important is not knowing just the basic formulae, but use those formulae to create your own what I'll call special cases. Okay, so special cases are like where you know specific information. For example, if you take a case of an object which is dropped from a height, okay, from the top of a building, and it reaches the ground. And typically we can be asked questions like, how much time did it take to hit the ground, or what was the velocity when it reached the ground. Now, all of these things can be found from kinematics equation. I think you already know that. But the thing is, this situation is going to occur multiple times. And every time if you put the values in kinematics equation and solve it, you will waste maybe 10 seconds, 15 seconds every time. And so all that time adds up very quickly. And also there are chances to make mistakes and things like that. So if you have all of these special cases ready, prepared as part of your revision formula sheet, then that will save you a lot of time. Okay, another very typical example is in the case of density and buoyancy. We often have some object which is floating in liquid. Then you should have the formula ready for what is the density of the object versus the liquid. So we will derive this formula today. That what is the ratio of the volumes of the submerged and the total volume. So all of these are shortcuts which will save you time. Okay, so all of this is important for this kind of exam because uh, time management is also one of the important aspects of doing well at an exam like this. Okay. And then the last thing that I think we should be well prepared is the mathematics part. So as we saw in the previous page that step two is solving the equations. So you should know that part very well. It should not be the case that you know the physics, but you got stuck in the mathematics or you made a mistake in the mathematics. So that should not be the reason why you were not able to solve a problem. So in mathematics, the basic things that you need to know to solve these problems is like basic linear equations, quadratic equations, simple simultaneous equations, like just two variables, very rarely three variables. And then some basic knowledge of vectors, like how to add vectors in one dimension and two dimensions, and some geometry formulae, like typical volumes, area, surface area, and things like that. So nothing advanced. All of this you already know how to do at the school level. Just it should be very efficient for you. It should not take time for you to do any of these things. Like if you just take the example of quadratic equations, you should know multiple ways to solve the equations, right? Like there is factorization. You know that b square minus 4ac formula, and quickly looking at the equation, you should formulate a strategy that what will give me the fastest and the most high probability of correct answer. So picking that strategy quickly is going to give you the advantage. because understand that competition is very high, that there will be lots of students trying for this exam. So every small edge that you can get, you should take it. Okay. Okay, so this is the again mostly general ideas about how to prepare for exam like this. So we'll start to solve the questions, but before that, I wanted to also introduce one concept which is called degrees of freedom. This is somewhat advanced concept, but I think it will be very useful to know this idea because it will help us to look at formula in a different way. So, like generally speaking, the definition which we can give for this degree of freedom is that if you have a situation or a system which has many variables, then how many of those variables can be given, and based on that you can find the rest of the information. Okay, so I mean, to illustrate this point, let us take something like simple interest. Okay, so like I think we all know the formula for simple interest, that simple interest is P principal into number of years into rate of interest upon 100, right? And then the amount is what, principal plus interest, right? So in this, you'll see that there are total five variables involved, right? The principal, the years, rate of interest, the actual value of the interest, and the amount. And then out of all these five, if I've given any three, right? Any three are given, then I can find the others, right? That is typically how the questions are. That in the very simple case, the P, N, and R are given, but it can be much more complicated than that also, right? But the point is that you need to know three of these values. Only then you can find the rest. So we say that the degrees of freedom of this system is three. Okay. It is as simple as that, nothing more than that. But the same is true for multiple situations. Like if I just go back to my slide. So for example, let us take kinematics equation. Okay. So in kinematics equation, you have all these variables, right? The initial velocity, the final velocity, the acceleration, the time, the displacement. So out of all these five, if any three are given, then you can find the others. Okay. So that is what the kinematics equation allow us to do. So knowing that degrees of freedom and knowing every combination, that if I give you these three quantities, how will you find the fourth one? So knowing all those formulae in your formula sheet is very important. Okay. So this kind of analysis you can do for every equation or every formula that you have in physics, or in fact, for that matter, even in chemistry and mathematics. Okay. So just keep this at the back of the mind that, the degrees of freedom are going to matter in lots of cases. Okay. So I mean, just to give you a snapshot that how, if you want to prepare a formula sheet, what are the things that you would like to include? So this is the most basic version. This is not what I want you to copy, because these are the formulae which are given in at the school level. But this is the starting point. That, for example, in kinematics equation, you have the basic equations, right? How to calculate initial and final velocity, displacement, things like that. Then, like this second line was the one which I was talking about, that, if I throw an object from the ground, how long does it take to reach the top? And, what is the velocity and things like that. And in fact, to this, you can also add the what is the kinetic and potential energy of the object, right? When it reaches the top. So those kinds of things. Then in terms of forces, just knowing the basic, like laws of motion, like basically Newton's laws are just saying that if you add up all the forces on any given object, then that will be equal to the mass into acceleration. And the forces can be of various kinds, that it can be gravity, it can be electrostatic force like the attraction or repulsion of charges, it can be buoyancy, etc., etc. Okay. Then momentum laws and energy conservation laws, like again, very basic things that, and it is very easy to create questions on these concepts, right? Because, typically you have some objects which are moving, initially, the velocities, finally, the velocities, and you can equate the momentum, for example. So we will do some examples of this also. Density and buoyancy, again, this formula which I mentioned just a few minutes ago, that the ratio of the volumes of the two, that the displaced versus the total object. So we will derive this formula in today's questions. Then for electric circuits, like Ohm's law is the basic thing, but using that to find equivalent resistance, I think you must be knowing this in school already, like how to find the series and parallel resistances. and then specific heat and latent heat, for example. So the last batch actually students had lots of questions around this. Many students are may have the confusion that what is heat and temperature, that how are they similar or different. So if I have time, I will explain this in more detail. But again, that concept is not that important to solve the problems. So we can just solve the problems based on the simple idea that total energy remains constant. And so you just equate the total heat gained by one object that has to be equal to the total heat lost by another object. Okay, something like that. And finally, optics. So again, optics, I will dedicate a fair amount of time because this lens equation can be confusing many times. Because as it turns out, there is not one sign convention. There are multiple sign conventions. And I think in school you are using what is called a coordinate signs. And after you start, preparing for JEE, you have to use a different so-called Gaussian sign convention. So we should explain that properly. Okay, this was just an overview of all the topics. This is the bare minimum that you should know, I would say that. And then based on this, as I said, finding your own special formulae that will help you to save time. Okay. But again, don't use this as a ready reference. Don't just copy this sheet and think that is all you need to do. This is my formula sheet. You should write your own independent formula sheet, which only you can write because that is how you have organized things in your mind. You cannot copy somebody else's formula sheet. That will not be useful for you. Okay. Okay, so these are the two question papers that we would like to do. So one is the November 2023 and the January one. And if I just look at the topics involved, so you'll see that some topics like kinematics equations have multiple questions on in both papers. And in fact, I'm going to do something different this time compared to the last batch because earlier I had just taken the questions in the normal order, like from the first question to the last question. But because of that what used to happen is that we had to do the kinematics equation question at the start and the end. But now let me go in a different order. Let me cover all the kinematics equations first. Like, so we'll go topic wise this time. Okay, we'll do one topic thoroughly and then we'll move to the next topic. But as a result, so I have to, the order in which we do the questions is not linear. So I've given the order also here if you want to know. But yeah, so we will cover all of these topics one by one. Okay. So then with that information out of the way, we can start actually solving. Any doubts anybody has up to this point? Okay. So feel free to ask because actually we don't have a very large audience this time. So it is a good thing because then I'll get much more personal interaction time with each of you. So any questions that you have, feel free to ask and we can take the time to answer them. Okay, if not, then let us start to actually solve the questions. Sorry, just one last thing I want to know. Can you raise your hand if you already attempted these problems before, uh, or all of you are looking at these problems for the first time? Anybody who has already? Yes, Harshvardhan, you have tried these problems before?
Yes, sir.
Okay, okay. Okay, but I guess for most of you, this is the first time that you are looking at the problems. Uh, So in that case, I will explain the problem and I'll give you just 1 minute to think about it before we start to discuss. Uh, so Okay, so I mean, what is the thought process that should go in your mind when you read a question like this? What are the things that you should start doing basically? So this is a question where some objects are moving, like some object is dropped from the top of the cliff, and at various points of time something is happening. At t equal to 0, something is happening. At t is equal to 1, something is happening. So your strategy should start to build in your mind that okay, I need to draw the pictures that what is going to happen at t equal to 0. Let me draw a diagram for that. So let me just show it in this way. Okay, so let us say at t equal to 0, what is the picture? So this is the ground, and this is some height of the cliff, and the object A is dropped from here. Okay, and at the same time, object B is thrown vertically upwards from the ground. Okay, so object B is over here, and it is thrown upwards with a velocity of u meters per second. Okay, so right at the start, we need to start taking care of sign conventions, because you see the object B is traveling upwards, but we know gravity acts in the opposite direction. So let us establish this sign convention that, anything that goes from bottom to top is positive, and the reverse is negative. Okay, so we will use this sign convention throughout all the questions, generally speaking. So therefore, then the acceleration is given by, uh, so the value of the g is, generally what we do is the acceleration due to gravity is written as 10 meters per second square, but then the actual acceleration is minus 10. Okay, so the reason why this is minus 10 is because we are falling to the ground, so it is negative. Okay, and so in fact, it is also useful to just calculate a upon 2, which is minus 5, because every time you apply ut plus half at square, you require half a, so therefore this minus half a is useful to just have in mind. Okay, so this is the starting picture, that object B is thrown upwards. Then let us fast forward to the next important moment, t equal to 1. So at t equal to 1, object C is also dropped. So at t equal to 1, what would have happened is, already the object A must have traveled some distance and picked up some velocity. Even object B would have traveled and picked up some velocity. And now we are introducing one more object C, right? And that is dropped from the top of the cliff, again with velocity 0. Okay. Then what happens after that? Uh, so objects A and C are in vertical line, so that is why I drew them like that. Uh, at t equal to 2, A and B cross each other. Okay, so this is an important moment, because this is going to give us information that, okay, at t equal to 2, now A and B are at the same level. So when I say that they cross each other, which means that they're at the same height from the ground, for example. Okay, and C is somewhere. I mean, at this moment, C doesn't really matter. And then finally, at t equal to 2.75, B and C cross each other. So as you can imagine that C is continuing to fall, and so at some point B and C will also be at the same level. And again, A doesn't matter here. Okay, so what we are observing, that these two pictures are giving some information, that here A, B are at the same level, and here B and C are at the same level. So we have to extract that information. So again, as I said that, we have to introduce variables. So for example, uh, when I say that A and B are at the same level, so I can measure the distance from the ground, right? So for B, let us say, so in this picture, right, at t equal to 2, what is the displacement of B? So SB is the displacement of B from the ground. So I can apply the kinematics equation ut plus half at square. So that will be u into 2 plus half at. So instead of plus half at square, I will be minus 5 into 2 square. Okay, I hope this makes sense. So because ut plus half at square, so that is why half a was replaced by minus 5 here. Okay, so this is the height of B from the ground, and it has to be equal to the height of A also, right? So it has to equal the displacement of A also. Okay, but remember, A started at the top of the cliff, right? So A was starting position was this. So actually, A's displacement can be computed like this, like from the ground, you first travel like this. So if I, let us say the height of this cliff is capital H, okay? So you first go from the ground to the top of the cliff. So that is you gain plus H, and then you come back using kinematics equation, right? So the SA will be H plus UT plus half at square. But here now, what is U? We are talking about A, right? So A start at a velocity of 0. So if A started at velocity of 0, which means that this term is not there, like u is 0. So I just have to write half at square, right? So therefore, the SA will be h minus 5 into 2 square. Okay. So yes, Harish.
Sir, value for the A will not be different for both different objects.
Value of A is not different for both objects because the same gravity is applied for both objects, right? So right now everything is falling under gravity only. So therefore all of objects have the same acceleration,
Yes, sir.
right? What is different was the initial velocity. For B, the velocity was u, so that is why this first term was there. For A, that initial velocity term was 0, so we did not even write it here. Yes, Prasanna?
Sir, why we have taken H?
So we had to assume some variable, that so initial position of A was at the top of the cliff. So I'm saying that that is h. Okay, I'm measuring all the distances from the ground. Okay, so the ground is, let us say the ground is at 0. No, we call the sea level as the 0. So from that, the starting position of A was at h. So that is why this plus h was there. And then starting from that position, then the displacement of A because of gravity is this much.
Okay, sir.
So yeah. And you see how the sign convention is helping. So because I am traveling from the ground to the top, so therefore this is plus h. And then the other part is negative because the acceleration due to gravity is negative. Okay, so I have to equate these two, right? Because what the diagram is saying that these two are equal. And so you see the advantage here, instead of solving everything, I can just see that directly these terms are going to cancel. So one important lesson is don't expand too early. Okay, so don't expand formulae early because sometimes they cancel. Okay. Okay. So keep this in mind, and multiple times this is going to happen. Yes, Harshvardhan.
Sir, in the essay, A is falling downwards, so we have take the gravity's acceleration positive. So why you have taken here negative?
So my convention is everything that goes downwards is negative. So otherwise I will be confused that what is positive, what is negative. So my convention is if something is falling down, it has to have negative acceleration. So that is why for both A and B, the acceleration is negative.
So as per our convenience, we have to take sign convention.
Yes, we are free to choose a sign convention, but once we choose it, you cannot change it. In half the question, if you choose one convention and the remaining half you choose the other convention, then that will not work. But once you pick the convention and follow it uniformly, then the answer will be correct.
Yeah, okay.
Okay. Any other doubt? Yes, Atharva.
Uh, sir, in SB, then the condition negative.
SB, why? Which part should be negative in SB?
So the acceleration you have taken negative, but
Yes.
positive.
Sorry, Athar, actually your audio is not very clear. So I understood for SBA you are saying that acceleration, why are we taking it negative? Is that your question?
Yes, sir.
Because acceleration is negative because it is pointing downwards, right? This is the convention that any vector. So the convention is vectors which are pointing upwards are positive, vectors which are pointing downwards are negative, and acceleration is a force, right? So force is pointing downwards. It is pulling the object to the ground. So therefore, the force is also negative and the acceleration also negative.
Yes, sir. Yes. Thank you.
Sorry, I'm not able to hear you. But okay, but let me continue solving a few more problems. Maybe after that it will become clear what is the advantage of this convention. Okay. But for now, understand that, some convention is important. Like if you feel that, you like to have the reverse convention, you are welcome. That let us say you want to take everything falling downwards as positive and upwards as negative, but that is very counterintuitive. So I will not recommend that convention. But like whatever convention you want, you can pick and use that. Okay. Okay, but let me continue solving this question. So I can equate these two and I get, what do I get? H equal to 2a, correct? H equal to 2u, sorry. Because the other term is going to just cancel. So this is the information I got from t equal to 2. Okay. In the same way, I can get the information from t equal to 2.75 also. At t equal to 2.75, again, I can find the how much B has traveled from the ground using the same kinematics equation. 2.75 square, correct. So this is how much the B has traveled from the ground, and C has also fallen from the same cliff, right? So again, to find the displacement of C, uh, so I can go from the ground to the top, right? So that is plus H. So that will give me H. And then I have to use kinematics equation, like ut plus half at square. Now, what are the values? Again, you see, the C is also starting at velocity 0. So this term is not present. Half a is again minus 5, and t is 1.75, right? Because C started from t equal to 1. So for C, the time difference is from 1 to 2.75. So the time is only 1.75 seconds. Okay. So therefore, this term is simply h minus 5 into 1.75 square. Okay, so I'm just repeatedly applying the same kinematics formula, ut plus half at square, just in different situations. Okay, and again these two have to be equal, right? And then finally, what do we have to answer in the question? What is the initial velocity of B? So we are interested to find the value of U. Okay, so if I equate these two, and again using this formula, I can eliminate H, right? I can replace H with 2 times U. So what is the equation I'm going to get here? That U times 2.75 minus 2.75 square is equal to 2U minus 5. Oh, sorry, I forgot to write 5 here. Okay, so you see, now we have converted the whole problem into just mathematics. Now I just need to solve this equation to get the value of U, right? So let me take U to one side. So I'm going to get 0.75 U is equal to 5 times 2.75 square. And you see the advantage, instead of calculating the 2.75 square, I decided to do it this way. By the way, this is not the way I solved the problem last time. So every time I solve the problem, I do it slightly differently. But that is okay, right? So because here I can see that I can just apply the a square minus b square formula, and conveniently a minus b, like the first term minus second term is just 1, right? So I can just write the a plus b term. So that is 4.5. And therefore u, which will be 30. Okay, so the answer is 30. Okay, so I'll again just give you 1 minute to observe everything what we did. So what are the important steps? That first, draw diagrams. Okay, draw clear diagrams of every important moment. Okay, then assign variables wherever required. So for example, this h was, we created a new variable. Uh, use a proper sign convention, make sure you don't confuse yourself, and then just use the information. So at t equal to 2, the fact that A and at B are at the same position, so we can equate their displacement. And similarly, at t equal to 2.75, we can equate these two terms. And then the rest was just calculation. Okay, if you understood all of this, then we can try the next question, which is you can see already here at the bottom right. So you'll see, in fact, the two questions are of very similar nature, that here also there are some objects which are getting dropped under gravity and things like that. So maybe I'll just give you a couple of minutes to think about the next question before I start to solve it. And right now we are progressing very slowly, but it is fine. We will pick up the pace once you understand the basic approach. Then later on things will accelerate. Yes, Harshvardhan.
Sir, when I earlier solved this example, I used one different method that I added the displacement of B plus displacement of A, and I equated it
Mm-hmm.
is equal to total height. And at that
Mm-hmm.
time also, my answer came U is equal to 30 meter per second. So is it a correct method?
I will have to see whether, sometimes, accidentally with the wrong method also you get the right answer. So if you write it properly and send it to me, then I can check it. But your idea is correct. It can work. But the only thing I will be careful is the sign convention, that if you use the signs correctly, it will work.
Yeah.
Okay. So let me do the next question. This January 2024. Okay. You see, again, very similar kind of setup, that you have some at t equal to 0, what is happening, that the object A is dropped from the top of the building or the cliff, and this is the ground. At the same, now all ABC are thrown at the same time, right? So A is also released from the top, B is thrown upwards, and C is also thrown upwards with different velocities. So B is given initial velocity of 9 meter per second, and C is given velocity of 10 meter per second. Okay. And then fast forward to the next important moment is when t equal to t1. So that is when what happens. Uh, so t equal to t1. So actually, the question is little bit confusing. Generally it looks like t1 should be first and t2 should be next. But if you look at this, that t1 minus t2 is 1. So actually t1 is t2 plus 1. So actually, which means that t2 happens first and then t1 happens. Okay, so slight, maybe deliberately to fool the student, but maybe. So let us draw the picture for T2 first. Okay. So at T2, C and A crosses. And that makes sense, right? Because C is accelerating, like C launched with higher velocity. So it will reach A first, right? And after that, only B will reach. So that makes sense. So let us say first C and A are at the same position. Okay. At T equal to T2. And then at T equal to T1, uh, A and B are at the same position, right? That is the information given in the question. And so again, very similar analysis should be applicable, like what we did earlier. And so for example, at t equal to t2, what can we say, that the displacement of C from the ground, which will be given by, so ut minus half at square. And you see, now we are able to write this very quickly, because now we have got the experience that, every time ut plus half at square, and substituting with one extra step. But if you can do that in your mind, it will save you time, right? So this half a is simply minus 5. So we directly write minus 5t square. And the same has to be equal to the displacement of A, which is again the height of the cliff plus ut. But again, u is 0, so I will not write any term here, and minus half a t square. Okay, so these two terms have to be equal, right? And so if these two are equal, conveniently the second terms are going to cancel, so that I can just write h is equal to 10 times t2. And the same kind of analysis can be done at time t1 also. So at time t1, A and B are at the same distance from the ground, right? So SB will be equal to, because B started at 9 meter per second, so 9 times t1 minus 5 t1 square. And SA is again height of the building, so H minus 5 t1 square. Okay. Uh, so again, equating these two, I can see that I can write H is equal to 9 times t1. So therefore, both of these together can be written as H is equal to 9 times t1 is equal to 10 times t2. And I have one more information about t1 and t2, which is this, right? T1 minus t2 is 1, or t1 is t2 plus 1. So I can solve these equations now. So if I, let us say, substitute t2 plus 1 instead of t1, so I'm going to get, right? And so if I solve for t2, I'm going to get t2 is 9. And what have they asked? They have asked find the height of the cliff. So we are supposed to find capital H. And so if I just put this value back in this equation, I'm going to get 10 into 9, which is 90. So therefore, the answer is 90. So you see how the previous question and this question were kind of very close, but with some small variations, the problem can appear to be very different. But really, we are just applying kinematics equation again and again. Okay. But you see some important lessons to learn. That first is that, this term 5t2 square got cancelled. In both cases, the term got cancelled. So, expanding that or doing anything to that would be unnecessary if it is going to get cancelled. So, observe these things to save your time wherever possible. There is one more way to do this question using the concept of relative velocity, but I will probably try to cover that at the end of our lectures. Okay, I will not spend time on that right now because it is not necessary. If this is the easier or more straightforward way to solve the problem is what we did just now. Okay, any doubts?
Sir, can you tell how you got -5 again?
Yeah, sure. So I mean that again, the idea is that the acceleration due to gravity is 10 meters per second square, but it is pointing downwards, right? So therefore, my sign convention says that I have to take it as a negative quantity. So A is minus 10, and so half A is minus 5.
Okay, yes, thank you.
Yeah. Okay, then let us go to the next question, question 12. I'll just wait for 1 minute.
Sure, so even if it's not given, we always take G as 10 and not 9.8.
Uh, in this exam, I can be sure and say yes, it has to be taken as 10 because the paper setters try to make the calculations easy for us. So that is why it is always given as 10. I think at the start of the paper, they will give you, right? If I remember correctly, they give it at the top of the paper. Let me just check that. I vaguely remember seeing that at the top. Like typically they'll give the chemical, the atomic masses, and some basic quantities they give. Sorry, Asar, I think your audio is not very good. I'm not able to hear you. They not given this. Oh, they are given there. So yeah, they will typically give it actually. Yeah, for this exam,
Okay, sir.
I can be sure that it has to be 10. Okay, so question 12. So here they have given a diagram. So this is where again observing what is given and what we need to find. So it is a velocity graph. Okay, so at every point we know the velocity of the object. At various points, how fast the object was. From that, I mean, from the slope of the line, we can find its acceleration and use that. But finally, we are interested in the displacement, right? So what is the net displacement of the particle? Uh, so you know the displacement formula is equal to ut plus half at square. But you should also know other formulae. So one of the formulae which is equivalent to this one, it is not difficult to prove. That is also equal to the average velocity. So which is the initial and the final velocity upon 2 into the time, right? And I think this is how we derive this formula, if you remember from your school textbook. So this other form of the equation is also useful. And see, this is where the degree of freedom idea comes in picture. That if you are given initial, final velocity, and the time, from this also you can find the displacement directly. Okay. So using this will make our solving this problem easier. And I think the best way to do it is by drawing a table where you have all the information. So, and basically for each part of the journey of that particle, we will see how much displacement was there. So basically, for duration or the time period. So basically, from t equal to 0 to 1, what is going to happen? So the total time for which the object was traveling was 1 second. The initial velocity. So at the very first, let me just zoom in into this diagram a bit. So here the initial velocity was 0. The final velocity at the end of the 1 second is 3. And so therefore, what is the average velocity is 1.5, right? And so I can find a displacement using this formula. So the displacement for this part of the journey is simply 1.5 into 1. And I can keep doing this like this, right? For each part. So for the next 2 seconds from t equal to 1 to t equal to 3. So the object was traveling for 2 seconds. And this is a constant velocity. So the initial and final velocity is both 3. So average velocity is also 3. And so the displacement in this part is just 2 3s are 6. And the next part from t equal to 3 to 6. So for 3 seconds, the object went from 3 meters per second to 4 meters per second. So average is 3.5, and 3 into 3.5 is 10.5. I hope you are following what I'm doing here.
Yes, sir.
Yes. Okay. And then the next part is a deceleration. It goes from +4 to -3, right? So from 6 to 13 seconds. So for a total of 7 seconds, the object was decelerating from +4 to -3. So the average velocity is 0.5. And so 7 into 0.5 is 3.5 meters. And then the last part of it I think came back to 0, right? So it came back to 0 in 3 seconds. So the average velocity is -1.5, and so displacement in this part is -4.5. And so if I just add up this column, that should give me the answer, right? So that is the total displacement of the object. So that is, this is -1, this is 12 plus 6 minus 1. So the answer is 17.
Hmm.
Okay, so you see, you can do this kind of question very efficiently if you have the right idea. Any doubts what I did here? So the key idea was just knowing that, so the interesting thing, we never found the acceleration, right? For each of these parts, you could have used the formula v equal to u plus at to find the acceleration. and then put that value in this equation. But this shortcut saved us some time. Yes, Harshvardhan.
Sir, in one book I have read that the in velocity time graph the area of that graph is
Mhm.
equal to the displacement. So I
Yes.
earlier used to calculate this distance by calculating the total area. So is it right method?
Yes, it is. Yeah, perfectly right method. And we can understand why actually here also, if you see what I'm doing here is calculating the area under the curve. So in your 11th standard, you are going to learn about calculus, which is differentiation and integration, where it will make more sense. But just to illustrate this point, which you have correctly pointed. So let us look at some term like let us look at the third row. Okay. So the third row, how do we calculate? We took three, the initial velocity, the final velocity, we took its average and we multiplied it by time. And so if you look at just this part, you know, so the area under this segment CD is this part, right? So what is the shape of this area? Can somebody tell me?
Trapezium.
Trapezium.
The trapezium. And what is the area of a trapezium? It is the sum of the parallel sides upon 2 into height, right? And isn't that what we did here? The initial, this is U, this is V, and this is T. So U plus V upon 2 times T. So that exactly the formula which we applied here is the area of this trapezium. And so we are just adding this trapezium. Sometimes it is not a trapezium, like the first part was a triangle, but in a way you can see triangle is also like a trapezium where one side is zero. So it is essentially the same thing. But you are correct that basically all of these are just, we are calculating one trapezium at a time. And this is in fact a very funny trapezium. This is like a half of it is positive, half of it is negative. But this the sign convention automatically takes care of it, and you get the right answer. But what you read is correct, Harshvardhan. Okay. Yes, Atharva.
So can you once explain the formula u plus v by 2 into t?
Yeah. Okay. Sure. So I mean the idea is that. Oh, wait, where does this formula come from? It is because, see, finally, what is acceleration? That the object starts at some velocity. Like let us say it starts at velocity u and ends with velocity v, right? Uh, so during this journey, you see that there is like a mirror image kind of thing, that at one point the object is at velocity u, at the end of the journey it is at velocity v. And so every part of the start, right? If I just take one small part over here, I can match it with the ending part of the same shape, right? So like there like I don't know how to explain this better, but like for every point, let us say u is 5 meters per second, and v is 10 meters per second. So at some point in this journey, the object was at 6 meters per second, right? Correspond to that, if I start from the tail end and watch it in reverse, then at some point it was at 9 meters per second also, right? So I can match these like pairs, like 6, 9, 7, 8. And so each of them gets averaged out. And so basically what happens is that at the average, which is at 7.5 meters per second in this case, right? So I can treat the journey of the object as if, instead of having increasing velocity, for the whole duration the object was at a constant velocity of 7.5. The displacement in both cases will be the same. Okay. And so therefore the answer is that if you just take the average velocity and you multiply it with the time for which the object was traveling, that will also give you the displacement. Okay. This is not a very rigorous explanation, but this is the best that I can offer right now. In 11th, when you learn calculus, you will see a better proof of this. But I hope this gives you the idea why this is true.
Okay, so thank you.
Yeah. Okay. Then maybe we can go to the next question. So what is given here? So we have Ram and Sham who are traveling along a straight line. So Ram starts running. So on the straight. So this is a kind of a question, and you can expect this kind of question where you have multiple stages, right? In different parts of the Ram's travel, he will have different acceleration and things like that. So first he accelerates at 1 meter per second square. Okay, so from here to here, let us say, so at t equal to 0, he is here, let us say, and right now he's accelerating. So I like to show acceleration like this wavy arrow, okay, often. So the convention I oftentimes use is that the solid line is a velocity, and this kind of a curvy line is acceleration. This is for my understanding. If you like this convention, you can follow the same one, but not compulsory. Okay, so he's accelerating at 1 meter per second square uh, for some time. They are not given how long. Okay, okay, and then from that point, he also starts decelerating. So now he is decelerating at minus 0.1. Why did I write it as minus? Because again, I have to pick a sign convention, and my convention for this question is that right is positive, left is negative. Okay, so therefore, in the first part, when he was accelerating, I used the plus 1 meter per second square acceleration. And the second part, when he's decelerating, so I've written the acceleration as minus 0.1. And then he comes to a complete stop at the end of this, right? And what is given is that he has traveled a total distance of s meters and in t seconds. Okay. So the first question is, can we, this like the point where he stopped accelerating and started to decelerate, can we find how much time it took? Like how much time was there in these two parts? Can somebody tell me? How can we find that?
सर नेट ऍक्सलरेशन काढायचं आणि मग ते एसच्या फॉर्म्युल्यात पुट करायचं.
हा पण एस एस तर आपल्याला काढायचंच आहे, पण त्याच्या आधी मला प्रश्न आहे की इथे म्हणजे पहिले किती वेळ तो ऍक्सलरेट करत होता हे कसं काढायचं? हाऊ डू वी फाइंड आउट हाऊ लॉंग यू वॉज ऍक्सलरेटिंग? If we don't know that, then we cannot solve the problem, right? So if you observe, see, what was his first part? He was accelerating at 1 meter per second square, and then he was decelerating at 0.1. So his rate of deceleration is 1/10 of the acceleration. So that should give you some idea that what will happen. Like if I draw this as a graph of velocity, okay? So this is a velocity versus time graph, okay? So initially his acceleration is very fast, right? So he's going to be accelerating very fast and he's going to reach a very high velocity, let us say. Now, his deceleration is very, very slow. So in fact, can I say that the time he will take to decelerate will be 10 times the acceleration time? Like if I call this as x, right? Let us say he took x seconds to accelerate. Then to decelerate, he will require 10x seconds. Why? Because the acceleration is 10 times weaker. Okay. Or another way to see the same thing is that, so if I say the velocity at this point is v, so initially velocity was 0, then it became from 0 to v, and then from v it became 0 again. So I can write the v equal to u plus at equation for both parts, right? So here, what is the equation? V is equal to 0 plus a is 1 into like t, if I call this as x. So the time, x is denoting the time, okay? So the time for these two parts is x and y. So v equal to u plus at. So this is the first equation. And for the second half, I'll get a very similar equation, right? Now, the change in velocity is from v to 0. So it is minus v is equal to uh, the initial velocity plus minus 0.1 into y. Okay, so y is the time for the second half. Okay, so if I compare these two, right, what am I going to get? Yes, Prasanna.
Sir, in place of minus v, can't there be 0?
Oh, sorry. Yes, I was also thinking I made some mistake. Yes, you're correct. It is the final velocity. Correct. So the final velocity of zero is equal to initial velocity v plus, so this is v plus at. Correct. So therefore, if I compare these two equations, you are going to get basically y is 0.1 y is equal to x. Or in other words, y is 10 times x. Okay. So I mean, this is the calculation way, but my expectation is that if you see this intuition that if it's accelerating at 1 meter per second squared and decelerating much slower, then this has to be 10 times longer. Okay. So if I split this t in the ratio 1 is to 10, then how much would each part be? Can you tell me what is the value of x and y? This is a typical like ratio and proportion kind of question. How much will x and y be if I split t in the ratio 1 is to
Of
10?
1:10.
Uh, no, I mean, if this is 1 is to 10, then how much is the value of x? So would x be t upon 11 and y will be 10t upon 11, right? It's like there are
Yes.
11 parts which are divided into 1 is to 10. So therefore, I now know how long Ram was accelerating and decelerating, right? Okay. So again, I mean, all of this was to explain. In the exam, you're not supposed to write all of this. So if you want to, become better at solving this kind of questions, then quickly observing that this is 1 and this is 0.1. So this has to be t upon 11 and 10t upon 11. So ideally in the exam, all of this should happen in your mind. Okay. So keep that in mind. So you see how solving many small steps like this, because we have done only half of the question. We have not even fully completed the question. But these insights are very important. Okay. Okay. So therefore, this first. So basically, Ram was accelerating for t upon 11 seconds and then decelerating for 10t upon 11 seconds. Okay. And so now I can find the total displacement. So S is going to be for the first part, it is simply half into A into t square. And for the second half, it is so now here the velocity v I can find, right? So v is uh, 1 into 10 t upon 11. So for the second half, the ut term is t upon 11 into, okay, so this is ut plus half a t square plus half. Now instead of a, I have to write minus 0.1 and t square. So t what 10t upon 11 square. Okay, so this is the total displacement of Ram. And then what does Sham do? So Sham is just running at constant acceleration of A, right? So I think Sham is just accelerating at A and he just covers the same distance in t seconds. So therefore, so basically this is also equal to uh, ut plus half a t square. Okay, and so in this whole equation, you see t square is going to cancel from all sides and A is the only unknown, right? So I'm going to get half A is equal to, so I'm not going to write t square everywhere because you can see that this t square is going to get cancelled with t square over here, t square everywhere there is going to be t square. So I don't have to write it also. And I think even half is going to get cancelled, right? If you see, there is half here, half here. There is no half here. Okay. So then I have to be careful not to uh, cancel that. Okay, so let me not cancel half right now. So half A is equal to half into 121 plus 10 upon 121. And then how much is this term going to be? Minus half into 0.1 into 100 upon 120, right? And so, as I said, everything else now we know, we just have to find the value of A. So A is going to be equal to, so I can multiply everything by 2 to get rid of this half. 1 upon 121 plus right? So A is 1 upon 11, which in other words, 1 upon A is 11. So I think the second half of the question was much more straightforward because basically Shyam's journey was very straightforward. It was just constant acceleration. But because Ram did this two-phase approach, like first accelerate, then decelerate. So the intermediate step was first to find out how long he was accelerating and how long he was decelerating. Okay, so that took us some time. But I hope the idea is clear. Okay, if no doubts about this one, then we'll go to the next question. Okay, so these were the two first problems. By the way, also observing the paper pattern. So in the first question 11 and question 12 are these two relatively simpler kinematics equations. Typically, the last question or one of them will also be kinematics equation based question. Uh, Sometimes it is a bit more involved. But when I say it is involved, it just means you have to write more equations. The equations are the same, just ut plus half at square, but just maybe the situation has to be properly analyzed. Okay, so for question 20, again, I will give you 1 minute to read it. Okay. So again, this pattern is repeated so many times that there are two objects or more than two objects, and they each of them have a different trajectory, and then at some point they meet each other again. So that this is also what is happening here. So here actually the police car and the thief car, if you observe, it is there is no change of velocity for the thief. They are just continuing to travel at 36 kilometers per hour throughout the question. So we will actually uh, just draw the thief here at 36 kilometers per hour and we'll focus on the police. Okay, so the police starts at velocity zero, right? At initially they are at zero. Okay, so at t equal to zero, the police car is just standing and then it starts accelerating at a constant rate. Okay, we don't know how much, but they're accelerating at some, let us say A is the acceleration. Okay, then the police car reaches a speed of 48 kilometers per hour in 25 seconds. So at t is equal to 25, if I just show it here. So at t equal to 25, the police car has picked up some velocity of what is 48 kilometer per hour. Okay. So yes, this was the question where I'm going to make an exception that, here the velocity is given in kilometers per hour, which is not a standard unit. In M case, we have to convert it to meters per second. But, I'm going to not do that. Okay. I'll give you a different way of solving this question where thankfully everything cancels out in the end. So we don't have to bother with the units, but I'll show how to do it properly. Okay. But anyway, I'll just to complete the information first. So up to this point, the car was accelerating. Now it is just going to travel at a constant speed for t2 seconds. So from this point onwards, for t2 seconds, the car is traveling. So therefore, after 25 plus t2, right, the car has reached somewhere over here, let us say. And at this moment, it catches the thief. So at this point, the thief has also reached the same position. Right? So therefore, basically, the total displacement of the thief from t equal to 0 up to this point has to be equal to, again, this two stage thing, that the first stage of acceleration and the second stage of constant velocity. So you see already the strategy in your mind should be clear that what are we doing here. So for that, first part, like how much is the displacement in the first part? So if I call this S1 and S2, right? So how much is the displacement in S1? So again, we don't need to know the acceleration. We know the initial and final velocity, right? The initial velocity is 0. So I can just write this is initial plus final velocity upon 2 into the time. So therefore, that is going to be 0 plus 48 upon 2, that is 24 kilometer per hour into 25 seconds. Okay, so and this is going to be 24 into 25. And so you see, I'm writing the units deliberately. So this is a very funny unit, kilometer per hour second. Okay, I have not cancelled any or not tried to convert the units into anything. I'm just writing the unit as it is, kilometer per hour second. I mean, you may think this is silly that there is hour in the denominator and second at the numerator, so they should cancel, and I will get 60 or 3600. But I'm just ignoring all of that. Okay, so S1 is this much, and what about S2? S2 is simply constant velocity, right? There is no acceleration, so it is just going to be 48 uh, kilometer per hour traveling for t2 seconds. So therefore, that is simply 48 into t2. Again, the unit is the same, kilometer per hour second. So this is S1 plus S2. And what about the thief? The thief was just traveling at constant velocity. So for that, so S1 plus S2, which is the total displacement of the thief, is simply 36 into the total time. And now you see the advantage of not bothering with the units. Everything is in the same funny unit, kilometer per hour second. So it is just going to cancel. Why should I bother doing any unit conversion? So this is a very uh, bold strategy, but it will give us the advantage of saving time. So if you want to use some trick like this, use it cautiously. Like don't don't be in a situation where you use some clever trick and then you made a mistake and which cost you the mark. Then it should be better to do it the proper way and convert everything into MKS system. So don't take shortcuts unless you are confident. But don't be afraid of taking shortcuts also, is what I'm saying. Okay, so I just have to find T2 here. And again, I'm not going to expand anything. See here, if you see, I did not calculate 24 into 25. Why should I unnecessarily calculate if it is going to cancel later on, right? Because now if I see here, if I regroup everything, I take T2 to one side and I can take 25 common. Where did I get is 12? 12 is 36 minus 24. So the answer is 25 seconds. Okay. So I'm deliberately showing these ways of how you can save time. I mean, just showing one simple way to solve the question is not sufficient. We also want to prepare you that how to efficiently manage your time and take shortcuts wherever possible. Answer is 50. Really? I mean, is my calculation wrong or you're looking at the answer key? Let me check the answer key.
Sir, no,
No,
it's
okay.
correct answer.
It is correct, right? Okay, fine. Yeah, because I did this question in the previous batch and nobody had any problem. Okay, okay. Is this clear then? What we did here? So again, worth learning something from every question. So take that learning and try to apply it for the next question wherever possible. But apart from that, this question was fairly straightforward. So we can go to the next one, I think. Okay, this one, question 20. See, they keep changing. In the previous question, it was police and thief. Now it is Ajay and Vijay. Previously, it was Ram and Sham. They'll run out of all the names, but it is just two objects which are traveling. Nothing more is happening. Okay. Okay, so what does Ajay and Vijay do? So Ajay is also running. Okay, and Vijay is also running. Okay, let us see. So Ajay runs from rest at a constant acceleration of a meters per second square. Okay, for time t1 seconds. So initially, let us say at t equal to 0, he is here, and at time t equal to t1, he reaches somewhere over here. So for this first part, he was accelerating at rate a. So at this point, what is the velocity that he must have picked up? It will be v into t1, right? Oh, sorry, a into t1. Okay. Then he runs at a constant speed for some time. So from here to the next 4 t1 seconds, right? So up to 5 t1. So for the next these 4 t1 seconds, he is running at a constant speed. So the velocity does not change. So the velocity remains the same at the end also. And then after that, he decelerates back to 0. Okay. So now he's from this point onward, he is going to decelerate, right? And how much? By a by 2. So again, using the idea of sign convention, we'll write it as minus a by 2 because it is deceleration. And he will come back to 0 velocity at, so they are not given how much time. But now, based on what we did in the previous question, can you tell me that how much time it will take to decelerate back to 0? See, if acceleration took him t1 seconds at when acceleration was a, and deceleration is half as fast, right? So would the time will be double compared to the acceleration, right? So this time will be
Yes.
2 times t1. Okay, so therefore at the final point, total time elapsed is 7 times t1. Okay, so this was Ajay. Then what about Vijay? So Vijay starts running also at uh, constant acceleration of 2a at time. So you see, very interesting. Vijay is also accelerating at twice the speed, twice the acceleration, but for half the time. So what will happen for Vijay? His acceleration is double, but the time is half. So therefore, at this point, the velocity he has picked up is also the same, right? The product is 2a into t1 by 2, which is still 8 times t1. So the interesting thing is here, Vijay and Ajay have the same speed at this moment. So this part of the journey, and now what is Vijay going to do? Vijay is also going to run at constant speed for 4 t1 seconds. Okay. So in this middle part, both of them are running at the same speed for the same time. So these are going to be equal. And this is going to be useful because finally, what is the question that at the end also he reaches the same position. And so when I equate the total displacement, I will completely ignore this part. Why should I write it when it is going to cancel? Right? So again, this observation is going to save me some calculation. And so finally he decelerates at a by k. So now from this point onwards, he is decelerating at minus a by k until he comes to the stop. And so again, for how much time it had to decelerate? So if the acceleration was 2a acceleration for t1 upon 2 seconds, then deceleration will last for 2k times, right? Oh, no, sorry. How to do this properly? Or let us say, I mean, this is becoming complicated, then we just know the velocity, right? The velocity at this point is simply this. So from velocity, we can just apply kinematics equation to find how much time it took to decelerate. So the time taken, so the change of the velocity is from 81 to 0, right? And that has to be equal to the deceleration times, if I say, what letter should I use for this? Just x. Okay, so I can find the value of x. K times t. Okay, so I know everything about their journey, like how Ajay accelerated and decelerated, and same for Vijay also. And he also covered the same distance of s meters. So this s, which is the total displacement, can be calculated for both Ajay and Vijay. But and I want to equate that, and in that I want to ignore these terms. So I'm not going to write them at all. So I'll just write the first part, the acceleration part for Ajay. So for Ajay's uh, total distance, the first part is ut plus half at square. So that is again just half into a into t1 square, plus this middle part, which I'll just write as m. I don't need to calculate it. And the last part is the deceleration, which is from, so the initial velocity of 81 into the time, which is 2t1 minus a by minus half into a by 2 into 2t1 square. So this is Ajay's total displacement, and Vijay's displacement is also very similar. First part again, u term is not there, so I can skip it. U into t1 by 2 square plus the middle part, which I'm ignoring. And then the last part is deceleration from 81 times uh, half into a by k into kt1 square. Okay, so when I equate these two, and so here itself, I can see what all is going to get simplified. And let us do whatever is possible in our mind. So m is going to cancel, and a t1 square. You see, all the terms have this a t1 square, and that is going to cancel throughout. So let us not write that at all. And so therefore, the equation I can directly write is half plus 2, and from here 4. So just minus 1 is equal to, so this was for Ajay, and for Vijay, what is that term? 1 by 4 uh, plus k, and here it is going to be k square upon, so k by 2, right? So this is the equation, and I want to find the value of k, right? Correct. So therefore, so this is just k by 2. So therefore, k by 2 is equal to, taking everything to that side, 5 by 4, right? So therefore, k is 10 by 4. And what are you supposed to find? 10k. So 10k is 100 by 4, which is 25. So the answer has to be 25. Yes, that is correct. Okay, so again, so this kind of a multi-phase problem is very common, that, almost imagine like if you've seen how a rocket is launched, that it has stage one booster, stage two, like every part of the velocity has a different thrust, different acceleration, deceleration. So it is like that. So you just calculate the parts and add them together, and wherever possible, take the shortcut. Even if you did not take this shortcut, it is fine. Like if you calculate m and equate it and cancel it, doesn't make much difference. But still, if it is possible, we should observe and exploit the situation. And this is deliberately given, like it was not by accident, right? The examiner expects the clever student to observe that at the end of this acceleration phase, both Ajay and Vijay have the same velocity. So if you observe that, only then you can take advantage of this. And this is going to become more and more common for more difficult problems. Like when you actually start preparing for JEE, you are expected to take these shortcuts. Otherwise, you will not finish the paper in 3 hours. Okay, so I think these are all the questions from kinematics that I wanted to discuss. So we'll move to the next topic, which is somewhat related, which is energy and momentum conservation. Okay. But before that, any remaining doubts about kinematics, let me know. Okay, if not, then let us go to question 18. So, uh, question 18 is, at first, if you're not careful, it may also seem like there are some objects which are moving. So, is it again kinematics equations involved? But the nature of the question should make it clear that there is no acceleration or deceleration involved here. Here, some collisions are happening. Some objects are colliding, the velocity is changing, etc. So, that should trigger the idea in your mind that this is probably related to energy and momentum, not kinematics equations. uh, so therefore, if I draw again, you should draw a diagram. So initial diagram, I mean, the initially what the diagram looks like is the 10-gram object is moving. Let us say it is moving to the right. So this is A, which is of 10 gram, and another B object is coming towards A in the same line. Its mass is not given, right? Okay, unknown mass. And its speed is also not given. So in fact, nothing is given. We don't know its speed, we don't know its velocity, but just that it is now going to collide with A. After the collision, what happens? A travels with the same speed, but in opposite direction. So after the collision, A is now traveling this way. And so now its uh, velocity is minus 1 meter per second square, right? And what happens to B? B also travels with the same speed but opposite direction. So B has also changed uh, its direction. Okay. Uh, and then what happens? Another object C is there, right? So C was initially stationary. So C was stationary in the first picture also, right? And now object B is going to come and collide with C. And after collision, what happens? B starts traveling with the same speed, but in the opposite direction. So you see, B is going to flip the direction one more time. So after the collision with C, B is back to its original speed, what was there before. And now this time C has picked up the velocity of 1 meter per second. Okay. And so the interesting thing is that, see, what is B doing? B is just doing the job of transferring momentum from A to C. In the end, B's momentum did not change at all, right? Initial momentum of B was mass times U in traveling to the left. Final momentum is also same, mass times U traveling to the left. So actually B can be completely ignored from our calculation. If I just say, so what is the initial momentum of the system? Is the moment of A, which is 10 grams into 1 meter per second, and plus momentum of B, which I'm ignoring, and C was at 0 anyway. Okay. And what is the final momentum of the system? So now at the final situation, A was started to travel at -1, right? And B was same as before. So this whatever term was, again, we don't need to know the value, but it is same. And then C was traveling at 1 meter per second, and its mass we don't know. So let me call its mass as X. And so what does conservation of momentum tell us? That the total momentum should be equal, initial and final. So therefore, when I equate it, again, these terms are going to cancel. And so I can just write 10 is equal to minus 10 plus X. So X is 20 grams. So you see, the actual calculation was just two lines. Just drawing the diagram made everything clear that what was happening. And most important, that B can be completely ignored. That is the important point. Otherwise, you'll have to assume some mass for the B and calculate the momentum. And you can do it that way, but it's just a lengthy approach, which is not required. Okay. Any doubts about this? Okay, I'll just give you 1 minute to copy. And meanwhile, you can also start thinking about the next question. And you see, now every question after question, this sign convention is helping us so much to make things clear that this A was traveling to the left, so we took its sign as -1. So in my mind, like this sign convention is fixed that upwards is positive and right is positive. It is like our 2D coordinate plane. And so anything which is going to the left or going downwards is negative. So if you also establish this kind of a sign convention in your mind, then things will be very easy to navigate. Okay, question 18. Okay, so there is a bullet which is traveling at it hits the block at 42 meters per second. Okay, so and mass is 10 grams and the block is stationary with a mass of 200 grams. So this is the initial picture before the bullet hits the block, and then it gets stuck in the block, which means after the collision, the bullet and the block are going to travel together. Effectively, there is a new object of size 210 grams, right? Which is the bullet and the block combined, and it will have a combined velocity v, which we can find by equating the momentum, right? So initial momentum is 42 grams into 10 has to be equal to the final momentum, which is v into 210. So therefore, I get v is 2 meters per second. So I know the final velocity of the combined object. And if the loss of kinetic energy, so typically what happens in collision, like just to understand the theory, when two objects collide, we know that energy is conserved overall, but energy can convert from one form to another. So we have what is called elastic collision, in which no energy is lost in heat or friction. In other words, kinetic energy remains conserved. Whatever was the kinetic energy before, like total kinetic energy, right, of all the object, does not change in an elastic collision. But most real collisions are not elastic. They are what are called inelastic collision. In an inelastic collision, some energy is lost to the environment, okay, in the form of friction. Like imagine a rubber ball which is thrown on the ground. So as the rubber has some friction with the ground, it is going to slightly warm up, it will lose some energy to friction, to heat. And so as a result, when the ball bounces back up, it doesn't have the same velocity as it went down. So every time it bounces, it loses a small amount of energy. That is why the finally the rubber ball stops bouncing and comes to a complete stop. If it were a perfectly elastic collision, then the rubber ball, I mean, ignoring, let us say, air resistance, it would keep bouncing indefinitely. Okay, so most realistic situations are inelastic. So even this is an inelastic situation, which is why they are asking how much kinetic energy was lost. Okay, and that we can calculate now because we have the velocities, right? So I know what is the initial kinetic energy of the system. So the block was stationary, so I just have to write half into for the bullet, half into, sorry, I should actually, this time I cannot take shortcuts. I have to do it in MK system. So 10 grams is 0.01 kilogram into 42 square. So this is the initial kinetic energy. And what is the final kinetic energy of the combined system? It is half into 0.21 kilograms into 2 square. And so the difference between this, the initial minus final, is the loss of the kinetic energy, what they have seen as E, right? So E, which is the loss of energy, is the first term minus the second term. So it just we need to calculate this. Which is this. If I take 0.01 common, I will get 42 into 21 minus 42. Yes. And actually we have to write 10 times E because maybe it is a decimal fraction. So 10 times E is 0.1 into, which is 84. 84 joules. Okay, so I mean, in this question, basically we use two ideas. First, use the momentum conservation to find the value of the velocity here. That was the first step. And the second step is, we should not say conservation of energy, but the fact that in a collision, typically some kinetic energy is lost, and we can calculate that. Okay, any doubts about this question? So this question and the previous one, these two were examples of applying conservation laws, right? Momentum and energy conservation. Uh, so this, I mean, all of these questions till now were about objects which are moving and things like that. So with that, we can go to the next topic, which is density and buoyancy. So for that, even before we solve the questions, just one small formula that will be useful to derive in this buoyancy topic. So let me just talk about that first. What is the spelling of buoyancy? Hopefully. So when an object is submerged in liquid, right? So if there is a liquid and some object, maybe partially or totally submerged, doesn't matter. So whatever part of the object is submerged, that experiences what we call the buoyant force, right? I think you must be knowing this from school already. So the object has experienced a force. Typically, it is written as FB for the buoyant force. And that is equal to, you must be knowing this. If I say the density of the liquid is denoted by rho, this is a Greek letter, which is pronounced as RHO rho. It looks like a P, but it is called a rho. Okay. Okay. Then the buoyant force is equal to, they say it is the weight of the displaced fluid, right? That is the buoyant force. Or I can write it in a different way. What is the weight? Weight is finally gravitational acceleration times mass, right? So how much mass of the fluid was displaced? And then I know what is density is mass upon volume, right? So this density is mass upon volume. So I can use that to convert this further into volume. So this is just going to be G times the density times the volume of the displaced fluid. Okay, in other words, how much volume of the fluid was displaced, that times rho into G will be the buoyant force. Okay, and now apart from buoyant force, there is also one more force acting on the object, which is gravity, right? And so if I denote that by W, because that is the weight of my object, right? And so what is the formula for W? W is simply the gravitational acceleration into the mass of my object, right? So this W doesn't have anything to do with the buoyancy, that the same gravity is going to act in all situations. But the comparison of FB and W will determine whether this object will float or sink, right? So if FB is greater than W, which means that the buoyant force is larger, it means that object will float. Okay. And if FB is not able to, if there is not enough buoyancy, then the object will sink, right? If the object floats, let us say, if the object floats, then we can write further something, because then when it floats, what is going to happen? The two forces have to exactly cancel, right? So FB and W have to exactly cancel. So in fact, no, this is the wrong thing to say. When the buoyant force and this are equal, that is when the object floats. If the buoyant force is more, it will push the object upwards, right? So it will cause the object to rise. But when the object has reached equilibrium, when it is neither rising nor sinking, at that point, the weight and the buoyant force have to perfectly balance each other. So here, if FB equal to W, and FB we just wrote here. So FB is rho, the density into G into V displaced. So the volume of the displaced fluid is equal to weight of the object. The weight is how much? The mass of the object into gravitational pull. And again, mass is volume into density, right? So now this time it is density of the object, not the liquid, into volume of the object into gravity. Okay, because this is the object we are talking about, not the fluid. And so if you see here now, G is going to cancel. And just to be clear, let me write here liquid. So this is the density of the liquid, and on the right is the density of the object. So if I rearrange this equation, what we are going to get is that uh, V displaced, that how much volume was displaced by the object upon the V total. Okay, what is the total volume of the object is equal to the ratio of the densities of the object and the liquid. Okay. I don't, is this formula derived in school? I don't know. Have you seen this before?
No.
Anybody?
No, sir.
No. Okay. Okay.
No,
Okay.
sir.
But this is going to be very helpful to save times. That is why I'm showing this to you. Again, just going through it quickly, no, not in detail. So the main steps that we did are, we calculated the buoyant force based on the weight of the displaced fluid, but we first converted the weight into mass, and then mass into volume, so that we got this rho GV, like rho into G into V displaced. This is the buoyant force, and then the weight of the object itself will be the mass of the object into gravity, and again mass can be converted into density into volume, and then cancelling G, we get this formula. And so this formula shows exactly what is happening. That so if I were to put this in English, what is the left hand side term? It is the what fraction of my object is submerged. Okay, that is what the left term is. That what is it? Is the half the object submerged, 1/10 of the object submerged, and the right is giving with the how much. Uh, so what is the numerator? The numerator is the density of the object, and that has to be lighter than the liquid, right? How much is the object lighter than the liquid? And understand, lighter is not in the sense of weight, it is density, right? So the object can be very small, like one small plastic ball, or it can be very large, like ship, for example. But in terms of density, which is heavier? Okay. So these two fractions are equal, which so quickly it gives you some ideas. Like for example, let us say there is a situation where there is a tank of water, and the water is at 1 gram per cc, which is 1 gram per cubic centimeter, is the density of the liquid. And let us say there is an object which is floating such that, okay, this is a bad diagram. Let us say if I look at it from the side, like in this right hand side question, you see how you are looking at the side view. So suppose in the side view, it looks like this, okay? There is a object which is exactly halfway submerged, okay? Exactly half is inside and exactly half is outside. Then how much will be the density of that object? Firstly, it is floating, so it has to be lighter than the water. So if the water has the density 1 gram per cc, the object will have a density of 0.5 gram per cc.
0.5.
Correct. So based on how much part is submerged, that gives you the density of the object quickly with this formula. Okay, and you can imagine other situations like this. So as the object becomes lighter and lighter, see what happens when the object is very light. When the object is very light, it means it has to displace a very small part of the fluid to get all the buoyant force it requires. So a light object will float very close to the surface like this, and a heavy object will have to sink further down to get enough buoyant force. And ultimately, when the object is so heavy that the entire, when the whole object is also submerged inside the water, and still the buoyant force is not sufficient to keep its balance its weight, that is when the object will sink, right? So all these pictures should be there in your mind that this is a light object, maybe like 0.1 gram per cc. This is a very heavy, maybe 0.9 gram per cc. And this is a even heavy, maybe 2 gram per cc, like a metal, which will sink. So like this is what is happening in various situations. Okay. So with this background understanding, we can go to the questions. Okay. So first question 13, let us try. Okay. I hope you have copied this formula. And this is nothing very complicated. If you just Google, you will find this formula in hundreds of places. But just knowing that is useful. Okay. So now the situation is like this, that there is a plastic block which is floating, and let me draw it slightly skewed to show the 3D view. Okay, so that plastic block, so it is in fact submerged in two liquids. There is a top layer of oil and there is a bottom layer of water. Okay, so this top layer is oil and bottom layer is water. So let me denote the volumes of these two parts separately. So the part which is in the oil will experience a different buoyant force, and water will have its own different buoyant force, right? So so if I say uh, P1 is the buoyant force of oil, so I'll compute this, and similarly I'll compute the force of water also, buoyant force of water, and both of the buoyant force will always act towards top, right? So both of them are going to try to push the object upwards, and that has to be balanced with the weight of the object, right? So the weight will try to pull the object down, and because the object is floating, which means that the sum total of all the forces has to cancel out. So the weight has to be equal to the buoyant force together. So this is the main equation which we want to solve, and then we just have to calculate all the parts. So the weight is of very simple because it is just a cube, right? So weight will be how much? Gravity into the mass of the object, and gravity into the, this is plastic of 0.75 gram per cc. I will use CGS system for this question. So I'll convert everything to centimeters and grams and into the volume of the cube, right? So the dimensions are given as 40 millimeter, which is 4 centimeter, right? So it's a 4 cross 4 cross 4 cube. So therefore it is going to be 64 cubic centimeter. So this is the weight, and that has to be equal to B1 plus B2. Okay. Now let us to find V1 and V2, we need to know how much is the volume, this, how much volume is in oil and how much is in water. And that this H which is shown in the question, that is what we want to precisely find, which we don't know. So let us say that is given by some variable X. Okay. So X centimeters are in oil, which means the remaining part is in water, right? 4 minus X is in water. Okay. So for the oil part, so if I just show the top part separately as a separate cube, right? So this is the part which is in oil. So how much will its volume be? It will be 16 times X, right? 4 into 4 into X. So therefore the buoyant force coming from here will be uh, the density of that liquid. So oil is, how much is the density of oil? 0.5 gram per cc, right? So 0.5 gram per cc into gravity into this volume V1. So this is the V1. And similarly, I can do the same for V2 also. So V2 has dimensions 4 cross 4 cross. The height is 4 minus X, right? So the buoyant force here will be again density of the liquid, which is 1 gram per cc into gravitational force into V2. And so V2 is 4 into 4 into 4 minus X. So I have all the parts now. I can combine all of this in this equation. So what I'm going to get on the left hand side, 64 into 0.75 into G. And on the right hand side, V1 and V2. So V1 is this 8x into G plus 16. So you see, many things are going to cancel now. I think G will cancel. 8 will also cancel. In fact, let me cancel 16. Okay. So if I cancel 16, so therefore 4 into 0.75. So I can find the value of X now. Oh, sorry. Ah, yes, correct. Oh, sorry, there is X here also, I forgot. Okay, so X is 2 centimeters, which means basically exactly half of the block is inside oil and half is inside water. Okay, let me just go through this once more in case anything is not clear. So again, the strategy was I have to equate the weight of the object which is pulling it downwards with the buoyant force. And the buoyant force was split into two parts based on the which part is inside oil and which part is inside water. And so if I assume the height of the oil part as X, so then I got the first volume as 16 times X and multiplied by the density of the oil. And the second part was the density of the water, which is 1 into this volume, which is 16 times 4 minus X. And then if I just add everything together, and then I will get the value of X. Okay, is this question clear?
Yes, sir.
Okay, we are almost out of time, but I think we can stop for just one last question so that we'll complete this buoyancy topic and we'll move on to something different next time. Okay, so question 13. So actually this question 13 is one where the formula we derived above, that will be very helpful to finish the question almost even without writing a single line, you can finish this question honestly. Because if you look at the formula that we had derived here, This one, right? The volume of the displaced upon the total with the ratio of the densities. And here, what we have to find d1 upon d2 is exactly this ratio, right? Then or rather the reciprocal of that. So what we are supposed to find is the density of the liquid upon the density of the object. So that will be equal to the total volume upon the submerged volume. And so this is where one, like I forgot to mention this earlier, one important idea from mathematics, from geometry comes is that what happens when you double an object, right? Like you know this from basic geometry, like if you take a square, okay, and if you double its side length, okay, when I multiply the side length by 2, the area becomes 4 times, right?
Yes.
Because both the length and the breadth will get doubled. In the same way, if I take a cube and if I double it, what will happen to the volume?
8 times.
8 times, right? Right. So basically, whatever is the fraction involved here, if the ratio is 1:k for the length, then the volume will go as per k cube. So simple concept, but using that here to quickly finish this problem, because this is a cone, right? So we know the formula for the volume of a cone, but we don't need to bother with that. Like if you look at the geometry of this object, like what they have shown here, it looks something like this, right? It is just two cones. The submerged part, right? The part which is inside the liquid is a smaller cone, and the entire object is a larger cone. So if I know this ratio of this height, right? This is what this h1 upon this is h2, this is h1. So h1 upon h2 is given to be 3. So this smaller cone is one third the size of the larger cone. Then what will the volumes be? Like this, sorry, not h1 upon h2. H2 upon h1 is given as 3. So the larger cone is 3 times the smaller cone in size. Then what will the volume of the larger cone be compared to the smaller cone? It will be simply 27 times, right? So therefore, the volume of the larger cone is 27 times the smaller cone. And this is exactly the total volume of the cone upon the part which is submerged in the water, or the displaced volume. And so if I apply the formula which we found earlier, this is going to be exactly equal to the density of the liquid upon the density of the object. And so the answer is simply 27 for this question. So really no calculations were required at all once you understand this formula. So you have to understand this formula, and you have to understand this cubic scaling, that as the object becomes 3 times larger, the volume is going to become 27 times larger. So these kind of questions are really where you should gain time, that, on an average, if you have, I don't know, maybe 1 minute to do every problem, or I don't know what is the average time you have per question. But this kind of question should take less than average time, so that whatever time you save can be used for the harder questions in physics or any other subject. So in general, in fact, I think physics on the whole should be a time saver. And that time you're going to require for mathematics. Okay. So both physics and maybe even chemistry should save you time to do more mathematics problems. Okay. So we will talk more about time management in the future lecture. But so we'll stop for today. We'll see you again on Saturday. Use the same Zoom link that I sent today, and we'll continue next time. Okay, that's all. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Bye.